All right, welcome back to Module 4, which is going to be just an algebra review. And I've made this comment already. This is an algebra-based physics class, and you already know all of the math that you need to know to be successful in this class. Okay? This is ultimately it's some pretty simple algebra. Now, here's where it gets difficult. We have so many variables and we have so many different equations and stuff like that. So it does get confusing, all right? But we need to be solid in our algebra content understanding before we can do anything more complex like the physics. And just try to keep that straight. That's why we're going to start with this algebra review. All right, so let's jump right into it. So here's my physics golden rule, and this is why we're doing this. We always solve things symbolically. So many times students are working on stuff and they show me what they're working on, especially during lab, because lab can be a difficult time. And they're like, I don't know where I'm going wrong. And I look at their stuff and I'll be like, I'll be honest with you, I don't know where you're going wrong either because I can't follow anything that you're doing. But if we solve things symbolically, and all that means is rearranging the equation for the right letters. So if I have x plus y plus z equals 17, and I say that x equals 3 and y equals 4, a lot of you, if I say, all right, well, let's solve for z, a lot of you will jump right into doing, okay, I got 3 plus 4 plus z equals 17. So 3 plus 4 is 7 plus z equals 17. All right, so z equals 10. And is that wrong? No. But here's what I want you to do. And again, this is just a really simple example. It's x plus y plus z equals 17. And we're solving for z. So I don't want you to plug in stuff. I want you to say z equals, I want you to get z all by itself. Z equals 17 minus x minus y. That's solving symbolically. That's getting your variable by itself before you plug in anything, which might seem like an added step, especially for an equation like x plus y plus z equals 17. But in physics, we don't deal with x plus y plus z equals 17. We deal with yf equals yi plus viy delta t plus 1/2 g delta t squared. All right, and I might ask you, all right, well, what's yi, right? I might be asking you where did that start, and if you have all these different variables and you're trying to get yi by itself, but you're plugging in all the variables first, it's gonna get frustrating and you're gonna get lost. And I'm telling you, I'm not telling you to waste your time. I'm telling you from my experience. Always solve things symbolically. All right, awesome. So the first stuff is the easy stuff, right? Some of these equations, super easy. So right here, I got, for the first one, v1 plus v2 equals 0. Solve for v1. Oh, well, that's kind of silly. v1, if I get v2 over here by itself, it's 0 minus v2, or v1 equals negative v2. All right, whatever. Easy one. Second one, I got a is delta is v over t. If I want to solve for t, I have to multiply it across. So at equals v, and I have to divide by a. So t equals v over a. Some of you might have been like, why did you just waste your time doing that? T equals v over a. I can do that in one step. If you can do that in one step, awesome. Do it in one step. If I'm doing something in class and I got from here to here, and you're like, whoa, I have no idea what happened in the middle, stop me and ask me, and I will explain. I will, if we need to redo formulas and show you more specifically how I got from point A to point C, that's totally fine. You want to understand where it's coming from. All right, here's our last one on this page. We have VF squared equals VI squared plus 2AD, and we are solving for VI. Okay, so the first thing I'm going to do is I'm going to subtract this guy over. So I have VI squared equals, I give VF squared minus 2AD. And then if I'm solving for VI, I'm going to take the square root of the whole thing. And I have VI equals the square root of VF squared minus 2AD. And that's it. right? So we're just solving symbolically. The other one, solve for d, a little bit more complicated. But I'm going to subtract, in this case, I'm going to subtract over the vi squared right away. So I got vf squared minus vi squared equals 2ad. If I'm solving for d, I'm going to divide the whole thing by 2a. And you got to be careful when you do some of this, because this is easy. This is very easy. But many of you make very easy mistakes because you mess up simple math, okay? And it happens, and that's totally okay. The nice thing about that is when we do problems, our answers better make sense. And if our answers don't make sense, that's a tall tale sign that you screwed up somewhere along the way. Okay, the medium stuff. Sometimes we have these formulas, and this is nothing but a formula here. It's actually one that we will use. It looks intimidating. It's not. And it says solve for VF if ti equals 0. Anytime that something equals 0, what I do is I cross it out and I say that's 0. So if I'm solving for VF, okay, wow, there's a lot going on here. I got to get rid of this m first. I want to get that over to that side. So I got f divided by m equals VF minus VI over TF. Okay, what's my next step? Well, I'm going to get rid of that TF. I'm going to multiply both sides by TF. And then I'm going to add this VI. Once the TF's on that side, I can add VI. So I'm going to get F delta T over M plus VI equals VF. And notice how it's not, this VI isn't on the numerator. It is added after the equation. So being careful, making sure you're doing the right algebra. All right, what about solve for TF if VF equals 0 and TI equals 0? So now I can say, oh, well, VF is 0. I should have changed colors. VF equals 0 and TI, oh, that was already 0. Perfect. So now I just have less variables. So sometimes it's just nice to rewrite it. M times VI over TF, and I'm solving for TF. So I'm going to divide by M, or I could multiply both sides by TF. I'm going to do that instead. F times TF equals M times VI. I'm going to divide by F, and I'm going to get TF equals MVI over F. This is all impulse and momentum stuff that you do not care about yet, and that's totally fine. Okay, the next one is we're taking a look at what we're going to be doing in Unit 3, which is conservation of energy. We're going to have a lot of equations that look like this, and there's so many variables. But a lot of times, solve for HF, which is right here, if HI equals 0 and VF is equals to 0. So anytime that I have a variable equal to 0 and other stuff is multiplied by it, I can cross out that entire thing. So VF is 0, this whole thing right here, that becomes 0. HI is 0, this whole thing right here, that becomes 0. Get rid of those terms before you even think about worrying about them. Okay, so now I have MGHF equals 1/2 MVI squared. And some of you that are algebra savvy and comfortable, you're like, well, isn't there an M in both terms? Absolutely. The M's cancel. And I'm solving for HF. So HF equals, I got to divide by this G over here. So I have VI squared over 2G. And that's it. Okay? So I'm not going to do the second one because I honestly just don't have enough room. So it's just going step by step, and that is called solving symbolically. Because imagine if I gave you values for M and other stuff. You would start plugging in these numbers, and if all of a sudden you're trying to solve for HF over here and you got all this shenanigans going around, you're going to get lost. So instead, we solve things symbolically, and then we substitute. So now if I had numbers, I would plug in the numbers at this point once I have everything solved. And that makes it so much more manageable. So we always solve things symbolically. All right, here's some more medium stuff, just because trying to get you to think about stuff. Our first one here, we're solving for L, and you're like, oh, shenanigans. All right, so if I add this L cosine theta over to the other side, Now I got L's on both sides. And if you're comfortable with math, some of you already know the answer. And this concept pops up a couple times. There's an L here, there's an L here. I can factor out an L. 1 minus cosine theta equals v squared over 2. Now I'm going to divide by the 1 minus cosine theta, and I get L equals v squared over 2 times 1 minus cosine theta. Is that okay? Yes, that's okay. Absolutely. Or you could say v squared over 2 minus 2 cosine theta. Is that better or worse? I have no idea. They're both right. I don't care. Okay. So remembering all of the tools that are at your disposal is going to be huge when you're solving things algebraically or symbolically. Here we got to solve for g. It's inside of here. All right, well, let's get the 2 pi over to the other side. So I got t over 2 pi equals the square root of L over g. Now let's square both sides. So t squared. What happens when I square 2 pi? Huh? I can't hear you. Sorry. It becomes 4 pi squared. Now that equals L over g. And if I solve for g, I'm going to end up reciprocating both. So let's get 4 pi squared over t squared equals g over L, and then multiply by L. So I'm running so far out of room. G equals L 4 pi squared over t squared. Should I move around the L, the pi, and the 4 up top? Sure, I don't care. All right, we're just trying to get variables by themselves, okay? All right, we got one more on this. I don't know if I have room for it. Solve for x if vx equals 0. Oh my gosh. Let's start real easy with this concept of vf equals 0. So let's get rid of this whole term. That equals 0. Here's a question. Could I cancel out my m's right away like I did on the last one? Now that you've thought about it, the answer is, of course, no. There is no m in this term right here. So even though there's an m here, here, and here, I cannot cancel them unless they are in every term because these are added together. All right, so I got this equals 0. Let's make it easy for us. Let's multiply everything by 2. So I get kx squared equals mvi squared plus 2mghi. And then I just got to divide by k and take the square root. So x equals the square root of mvi squared plus 2mghi all over k. Some of you might be getting overwhelmed right now. And to that, I would suggest doing the optional practice, okay? There is so much of this. This is so much about that we're going to deal with physics. And you're like, I thought I signed up for a science class. You did. This math is not new to you. We're just using it in new ways. All right, here's a little bit more of the difficult stuff. And the difficult stuff isn't actually really difficult necessarily. But here's the concept. If I have two different ways of solving for something, so here I have what this is that the frictional force is equal to the coefficient of friction times the normal force, and the normal force is equal to this, mg cosine theta. I can solve for something in terms of, I'm solving for mu in this case, in terms of these variables. So what does that mean? It means I can take, here's my equation 1, here's my equation 2. I can combine those equations and make a new equation with different variables that's still true. So instead of f of f equals mu fn, it's f of f equals mu, but fn here is mg cosine theta. Mg cosine theta. This is called a system of equations. I have two different equations, and I am substituting them in for each other. And we're going to do this quite often because it comes up quite often. All right, so if I'm solving for mu, I'm just dividing by everything else. So mu equals, nope, I went the wrong way. F of f divided by mg cosine theta. That's an m, not the mu. It kind of look the same. So that's my formula for that one. All right, system of equations. The second one here, we're solving for R in terms of FC, M, and V. So I know FC is MAC and AC is V squared over R. Notice how there's no AC in this equation, so let's get rid of that. So FC, it's MAC, but AC is V squared over R. So if I want R by itself, I need to, let's multiply it over and then divide by FC. So R equals MV squared over FC. And there that is. So this is setting up systems of equations. I think this is probably an Algebra 2 thing that you guys do a lot of this. I could be wrong about that. Again, throw it in the comments below if you know when you learn how to do this. So here's the question, why are we doing this? And my answer to that question is, of course, a question. And my question is, well, you signed up for this class. What is physics? And I'm going to let you ponder on that for just a second, because many of you signed up for this AP Physics class. AP Physics, what does that mean? It's a college physics class. So you sign up for a college level of physics, but I would venture to guess that many of you can't really tell me what physics is, okay? Which is a scary thought, but it's okay. By the end of the year, you'll have a pretty good impression. Here's my explanation of what physics is. Physics is the explanation and quantification of the phenomenon of life. So what does that mean? We see things in life happening, and we explain why they happen, and then, furthermore, we determine or derive equations that explain what's happening. So here's an example. I have just a ramp here. This ramp is on some angle theta. There's a ball. What happens to that ball? The ball rolls down the ramp. Why does it roll down the ramp? Okay. Many of you probably have an idea. Something about gravity. Gravity pulls it down the ramp. Absolutely. How fast does it go down the ramp? What's its velocity? And the answer is, well, it depends on where it's at. But I know that the rate of acceleration is g sine theta. I know that the initial velocity is 0. I could solve for the velocity here based on the displacement that it undergoes and the angle of the ramp, okay? So what does that mean? I can quantify how fast it is. I can tell you at a certain amount of time how far it's gone. I can tell you what its new velocity is when it's at the bottom of the ramp. There's so many different things I can tell you, and they all use equations. So our equations are backing up our physical phenomenon explanation, and that's what physics is, the quantification and explanation of the phenomenon of life. And it takes both. It takes understanding why, and it takes quantifying it to really understand and be able to explain. And that's what physics is. That is what you signed up for. I love it. Some of you will love it. Some of you will absolutely wish you took something else or whatever. But it's fun. The labs are the most fun labs you can have in a high school science class. Your chemistry labs suck, okay? Your chemistry labs are stupid. You know what's not stupid? Physics labs. Physics labs are fun, and they're awesome, and the class is awesome, so I'm super excited to work with you guys this year. I will see you in Module 5.